Hello everyone, it's October 31st, last day of October. Alright, let's take a look. Flatten a multi-leveled linked list. Ooh, look at that. We've done it 2020. Alright, let's take a look. We're given a doubly linked list, which in addition to the next and the previous pointer, it could have a child pointer. We have a next, previous, and a child. Ooh. So may or may not point to a separate doubly linked list. The child lists may have one or more children of their own, and so on, to produce a multi-level data structure, as shown in the exact example below. Holy guacamole! Look at this. I need to shrink this just to make it easier to see. Flatten the list so that all the nodes appear in a single level, doubly linked list. You are given the head of the first level of the list. So we have this monstrosity. What are we trying to do? So 1, 2, 3, 7, 8, 11, 12, 9, 10, 4, 5, 6. Okay. Head 1, 2, no, 3. The input is always been 1, 3, 2. How multi-level linked list is? I remember I even wrote. Oh, I remember this. I think I even wrote a simple program to output this as well. So it'll be 1, 2, 3, 7, 8, 11, 12, 9, 10, 4, 5, 6, right? Serialization of each level. To serialize all levels together, we'll add nulls in each level to signify no node connects to the upper node of the previous level. The serialization becomes and then the first is null because it's connected to the third one, so some and no. Merge in the serialization. Oh my god. Okay, so I think the reason I wrote something to basically parse the input is I wanted to write test cases myself, but these days I never do test cases with linked lists or trees. It's just not worth it. So the ideal is we're gonna go. Or once I have a child, then I can do flatten the child, and after I flatten the child, I will return the tail of the child, right? So after I flatten it, I'll return the tail. So at 3, I'll flatten this, and at 8, I'll flatten this. I'll return this. So I connect this one to this one, and that shall be it. Let me try. Yeah, I think a simple recursion shall suffice. Alright, let's take a look. Alright, hold on, I have something else to take care of. Alright, I'm back on track. So I think I need both because I need to define this class definition of a node. Alright, so we need to flatten it. Oh, that was old notation. I think we can nowadays just use node. Alright, so what do? Well, we want to flatten, right? So we flatten, we have a head. We're going to see a node, right? So we say we're gonna return. Oh, we need a helper because the helper will return a tail. So we're gonna have a head, right? Head is gonna be a node, and I'm also gonna return a node, right? So I'll say node equals head, and while node, right? While node. What if its node is nothing? Well, if it's nothing, we just return. What do we return if it's nothing? We should return nothing, right? Hold on. So while node, we're going to check, right? If node dot child, then new tail shall equal to helper node dot child, right? Because node dot child will flatten the child, and after we flatten the child, we got a new tail, right? So node, so I have a child, right? So after we do this, the child is the head, so this one all done, and I return the tail. So now I have head and tail. So what we're gonna do is get its next, pointing to my child, and oh, hold on. This is actually, so let's have a temp equals node.next, right? And then node.next will equal to node.next will be equal to node.child, right? And then the tail, right? So the tail's next. So new tail. I just call it tail, right? So tail dot next. So tail's next is going to be temp, right? And temp dot pre is going to equal to tail. The tail's pre is fine, right? And while node, if node.child, we do this. And node will equal to temp, right? Because we skipped the entire thing, so node equals to temp. Else, node equals node.next, right? And then equal node.next, eventually we'll have nothing, right? Have nothing, comes back. So we need to go, because I need to return the tail. I should say node.next, right? So node is the head. What if the head does not have next? Well, if the head does not have next, that means well, it will not be. So we'll always check. So this node must not be none, right? Node must not be none. If the node is not none, then we always have node.next, right? But if we don't have node.next, I have node.child, what are we going to do? That's a question. Because I can have this by myself, but I have a child, right? So I do need to check for node, but I need to say tail, right? Tail will equals to head as well. So initially, node and tail will both equal to head, and this cannot be tail. This has to be temp tail. Alright? I have a temp tail and I have a temp. So, and every time, while node, if node.child, blah blah blah, if not, node equals node.next, and then while node. So node equals node.next. How do I check the current while node, right? While node, tail equals node. Because node is right? So, and then if I come out, the tail will always point into the final true node. And then, I'm in the cases if I have a head by itself, and then there's nothing left. So while node what goes in, tail is going to be by itself, and then I have child, then I handle the entire child, and I get the temp tail, and then node equals a temp equals node on next, which is none, right? And node on next equals node on child, that's fine. And temp tail dot next equals temp, which is none, which is fine. And temp dot pre, well, temp does not have pre because temp is a none. So we have to say if temp, then temp dot pre will equal to temp tail. Otherwise, we don't have to do it. And then node will equals temp, move the next one, right? Otherwise, node equals node on next. If it doesn't have node on next, comes back while node coming out, right? Once I'm coming out, I'm going to return tail. So this one will return tail. This means we are going to do helper head. That's it. And then I'm going to return head. All right, let's try this. I have a runtime error. Okay, that's probably because we need to allow this. That's not correct. Do not valid. Doubly linked list. Oh, we have some part not doubly linked. Interesting. Where did we not double linked? Everybody has to be doubly linked, right? And a helper, so this one comes in. I just run it through. While node, tail is here, and then I say if node.child, no, so no equals to node.next, no here, no here. Now I'm here, node.child is true, so I come here, I say temp tail equals helper node, so a helper runs this, right? So it goes in here. So start with this, node.next, and then node.child, boom, will come here. That's the starting node. Node dot next. So tail is equals to node, and then node.child is nothing. Node equals node.next comes here. Tail equals this. If node.child, no, so node equals node.next. Now it becomes nothing, right? Now it becomes nothing. Come back, node escape. So tail is pointing to this. So I return this. So when I call here, right? So this one returns this node. That's the tail, temp tail. Right? That's the temp tail. Now we have a temp tail. I say temp equals node. Node is here, right? Node dot next. So this is the temp. I say node dot next equals node dot child. Okay. Should I also invalidate node dot child? Right, node dot next equals node dot child. So the next pointing here. Oh, the child didn't point back. Ah, that's the problem. The child needs to point back. and then temp tail, I immediately go temp tail dot next, this one on next, equals temp, I say if temp, then temp dot pre equals temp tail, and node equal temp. Yeah, I think I missed one, which is node dot next equals node dot child, right? And node dot child dot pre equals node, and node dot child equals none. Right, I have to go through this. All right, try this one more time. Can actually use more test cases. Yep, I think this one's right, hopefully. Nope, I have a wrong answer. 1 no, 2 no, 3 no. What is this? 1 no, 2 no, 3 no. 1, oh, I have to parse this. 1 no, 2 no, 3 no, right? Because each ending on no, so that basically is 1 child, 2 child, 3. Okay, 1 child, 2 child, 3. Let's see, 1 child, 2 child, 3. So we have a 1 no, 2 no, 3 no. What case I did not expect. So in this case, 1 passing in, I immediately go to the child. And then 2, immediately go to the child. So now I'm at 3, right? This one will be 3. Node is 3. Node and tail both are 3. Well, node, tail is equal to 3, right? That's good. And I say if node dot child, which is not, then node equals node on next, which is none. Coming back, escape. We now return tail, which is 3 itself. Okay. So now at 2, right? At 2, temp tail equals 3. Temp equals node on next. Temp is none. And then node on next equals node on child. Node on next equals 3. Yeah, node on next equals 3. And node dot child dot pre equals no, that's true. And node dot child equals none. And tail, temp tail is a 3. Dot next equals temp, which is none. And then temp. Oh, I think I know the problem. I think it's the same problem I had the first time. Because the tail has changed. The tail has changed. So once I finish this, right, if I call this and I keep going, the tail. So node will equal to temp. And that already is gone. How do I update the tail? We want to return the tail. The tail, oh, I see. We need to update the tail. So because the temp might not be a real node, so when we do this, tail needs to equal to temp tail. Well, in that case, then that is not a temp tail, right? That's just a real tail. Because that is, from my perspective, I'm looking at my child. So the current tail just become the child's tail, right? And then no equals this. When I go back, if I can go back, then I have a new tail. So let's try this. Wow, if it still take like 2 tries to get it right, then I'll be very disappointed. Alright, so now we finished this, right? We got this right. Alright, try it again. Hopefully this time is good. Yep, so we improved because previous, oh, that's a runtime error. That's probably just a silly error, so we flatten of a dummy. Doesn't look nice. Oh, it go faster. This is a wrong answer. Helper. Flatten. Okay, what's the accepted? Let's take a look at the accepted I had in the past. Remove. I have a dummy node, and this time I don't have a dummy node. Now, child, I do current flatten. Yeah, and I say if node.next is not known, return the last node. Then return this. Otherwise, return self.helper. I don't know. I don't know what I was doing, but I like this version better. So basically, this version says, right? This version says we traverse the linked list until we encounter a node that has a child. We flatten that child. We flatten the linked list rooted at the child and return its tail. Then we rearrange, right? We rearrange the current node. Then we insert, right? We insert the flattened child linked list and continue. All right. So one piece of tricky part is that a child linked list could have its tail being its own child linked list. Thus, we need to reassign tail each time we process a child linked list. I'm not sure if it makes sense, but this is basically reassign tail in case child linked list has the real tail, right? Has the real tail. That's the only thing. And this is already ON, everything with the ones. Now I have 36 milliseconds. The 76. Yeah, I think this one is pretty straightforward. Nothing too special. And I think we have capacity to roll another one. Yeah, because LeetCode start to recycle problems. Right? They recycle problems. We don't like it. We want to try new things. Right? We want to try new things. Ah, look at this. They put this at the top again. 161 days of streak. Sometimes I want to say I want to post my streak, but what's the point? Right? What's the point? I mean, can I even see my streak somewhere just to, give myself a pat in the back? DFS was stacked. Why would you DFS with stack? Anyway, so that will be it. Yeah, can I see like my streak? I don't think I can see the streak. Study plan, December. I think it just means like I've done everything. Yeah, I don't think I can see my streak. That would be interesting if I can have some place to show my streak. I actually forgot my streak. 400 and something. Alright, anyway, let's not just get tangled on this. Let's pick another one. Let's roll another one. Yeah, we call this one a day. 4:30. Okay, let's try this one. Mini parser. Oh, people hated this question. What the hell? Why? You should implement. Oh wait, this interface that allows for creating nested lists. You should not implement it or separate about its implementation. Oh, people have strong opinions about this. Given a string representing a serialization of a nested list, implement a parser to deserialize it and return the desired nested integer. Each element is either an integer or a list whose elements may also be integers or another list. We shall return a nested integer object which contains a single integer 324. And this one shall return a nested integer object containing a nested list with two elements, an integer containing value, a nested integer containing two elements, an integer with value, and nested integer. So S consists of digits, square brackets, negative sign, and commas. S is the serialization of a valid nested integer. All values are within. Okay. This is the interface. Let's read through this. This is the interface. I'll just copy and paste this whole thing. Yeah, I mean, that's fine. I don't really care if people upvoted or downvoted. A question is a question, right? It can be a good question. It can be a bad question. In my book, there are bad questions, but that doesn't decrease the value of solving them. You got to solve all types of problems in your life. So bad questions are still questions, right? I just solve all questions, but we don't need test cases. Okay, so what are we talking? So we say this is the interface. So I don't have to do this stupid thing. Let me check here. Allows for creating nested lists. You should not implement it or speculate about its implementation. So it's a big class, but I think I can call it, right? If value is not specified, initialize an empty list. Otherwise, initialize a single integer equal to value is integer. Return true if this nested holds a single integer. Add, set this nest to hold a nested list and adds a nested integer element to it. Wait, is element? What is element? Set this to hold a nested list. Add, it could be an integer by itself, right? Or add a new element. It could be a nested in a list. Okay, this is a nested integer. This is a nested integer. Set integer. Set this to hold a single integer value to this. Get integer. Return the single integer that this one holds if it holds a single integer. Return none if it holds a nested list. What if it's an integer and a list? Oh, then that means it contains a nested integer. Okay. Get list. the nested list that this holds. Okay. All right. So we parse it first. All right. So, how do we parse it? Well, it's going to be parentheses, right? It's going to be parentheses and we have a stack. So we're going to put left bracket goes in, and then if it's the integer, we just, or if it's a negative sign, we gonna string all the way, because if it's an integer, it will end with a comma. So we scan the entire thing, we get the integer, so we push the integer in, so we push 123 in, comma. How do we handle comma? Well, comma means it is a nested integer. Comma means it's going to be a nested integer, right? So hold on, let me think. It's going to be a nested integer. I can accept another comma, and we can like not handle. Yeah, we can not like a comma. What if we just ignore it? And the next one comes in is another bracket, another value, ignore it, another bracket, another value, and boom, we hit a first right bracket. So we hit the first right bracket. So once we hit the first right bracket, we go inside, right? We go inside the stack, and we pull out an integer. Okay, and then, well, there could be multiple integers in it. So we pull out let me think. Nested integers. I mean, eventually, right? Eventually, we're gonna have a list of. Wait, can I have a list of integers? I guess that's also true, right? Each element is either an integer or a list, right? So the first time I have a right bracket, right? The first time I have a right bracket, which means the most nested element, it must be all integers, right? Yeah, it must be all integers. So I just pop until I find the first left bracket, and all of them can be, they belong to the same nested integer. How do I do that? So we add, right, to hold a nested list, and it adds a nested integer element to it. So I just add, just keep adding. So, oh, but it will be reversed. It will be reversed. Holy guacamole. It will be reversed. And let's not think about this first. Let's just pop, right? So everything popped out until we find the left bracket, and all of these, I'll just reverse it and push it into a bracket, right? Push it into a nested integer. So now we have a nested integer to handle the most deeply nested one, and we push that into it. I'll push that into it. Oh, so every time we get an integer, that is a nested integer as well. So we can create a nested, so everything is a nested integer when we push in. And then when we pop, that's a nested integer, right? And then we can add, right? So we create a new one, we add all of them in. And then we push the new one in, and then we hit another right bracket, and then we pop until okay. So for this one, it's going to be I have to reverse, and I do not like to reverse. So what if we go from the end to the front? So we'll have right bracket in. So we have right bracket, boom, 789. Holy guacamole. Then we go the other way, right? We go the other way. And it will end with either a parentheses or a left bracket. So anything that's not a digit or a sign, right? So I keep going until we hit something that's not, and then we can turn that into a value. And once we turn that into a value, we turn that into a nested list, and we push in. And the next one, boom, we hit a left bracket. So we hit a left bracket, then we pop whatever is in. So we create a new nested list. Whatever is in, we're going to push in. Right? And then we're going to pop the right bracket as well. And then we push the new things inside. And then comma, ignore. The next one, boom, 4, 5, 6. So we'll push 4, 5, 6. And then, boom, we hit another left bracket. Okay, so we hit another left bracket. We pop 4, 5, 6, pop off first. And then 789. So that create a new list, right? And push in. And then 3, 2, 1. Yeah, I think this might work. Alright, let's try this. Deserialize. So what do? So we need a stack. Right? And then we're going to go from bottom to the first. So we're going to take 4, I in range, len s minus 1, minus 1, right? And then we say, if it's a right bracket, we say if not stack. Now, if si is equal to a right bracket, right? If it's a right bracket, then we add to the stack. Append si, right? Else. Now we're gonna handle and we're gonna ignore the elif. Elif what? Elif si is equal to a left bracket. Now this is all hell break loose here, so we're gonna do this later. And elif si is not equal to a comma. That means this is a number, right? And then what we're gonna do is while, let me say j is equal to I, right? So while sj is not in, I'll just say not equal to, comma, because we are going forward. So the only time we're going to stop either comma or left bracket. So either it's not this or sj is not equal to a left bracket. That means sj is a number, right? And then we're going to say n equals to 0, and n going to be plus equal to 10 times n plus int sj, right? So 10 times n plus this, and I've got another one, 10 times this, basically just left shift, and then plus the new, oh, no. That is not correct. That is not correct. It's 10 times, holy guacamole. We have to also compute how many times these are times 10, because it's not, if it's on the left to right, we can use this trick. But the right to left, we cannot use this trick. Because the first one is this. The second one, we need to, oh, can we have, we bloody cannot. We bloody cannot. We need, huh? Alright. How do we figure out? We need to figure out how much power to give. Which means that's going to be int this, right? The times 10 to some power plus n. What power? Will be I minus j, right? Yeah, n is 0, so the first one, I is equal to j. So that's 10 to the 0 power, which is 1, is by itself. Yeah. And then all the way to until, yeah, that should be fine. So j minus equal 1, right? And then this one will give us the number, the value, right? So the value. And once we get the value, we need to push this value into it. So we can call stack dot append nested integer. Call it nested integer value equals n, right? So we push this in, and once we're done, and I just realized that the I needs to, okay, so we can now use this. I equals len s minus, I have to use a while loop. So while I is larger equal to 0, and we do blah, so we do blah, I minus equal 1, right? And then we do blah with later, and else if it's not, then we'll blah blah blah, and I will equal to j. And actually, we don't need j anymore in this case, right? We can just use I. We can just use I. So we're going to say, well, this is not this, and this is not this. Oh, we cannot. We do need j because I need to calculate. Holy moly. So j equals I, so j goes first, and then I equals j, right? And the last case will be, or the other case, I gonna minus equal 1. But in this case, right, let's just not do this, and we say j plus 1. So then I minus 1, that's fine. So wait, this is fine, so now the last thing we need to take care of is here, right? So si is equal to this. So now we need to pop from the stack, right? how do we pop from the stack? Well, we need to create a new thing, right? Create a new thing called nestle, and we need a res. Res equals to nested integer, right? And then we can say, right? We can say, I say what? We can say gonna pop from the stack. So I'm gonna say new nested integer will equal to, well, it depends on how many do we have, right? Well, each one is, I'm not sure. Like, I'm pretty sure if I do this, that probably is not right. We can try it first, right? We can try it first. Because I want to push it in, it's a nested integer already. So we can just take it out. Hold on. Hold a sec. If I have multiple, it could either be an integer or a nested integer, right? So that's a requirement. It can either be an integer or a list whose elements may also be an integer or other lists. So should I push in the nested integer or should I push in the integer? It seems like we should push in the integer. Okay, if we push in the integer, then what's the point of using this technique? Because if we push in the integer, then when I put it out, all right, push in, and I will put it out, the first one comes out, but I'm not sure, right? I'm not sure what because the add, I think I got confused by the add. Add is set this one to hold a nested list and adds a nested integer to it. It's like, what if I have a list of multiple integers, right? What if I have a list of multiple integers? Do I do add an integer or do I add a nested integer? Yeah, I think that is the confusing part. I don't know. I'm gonna try. What if I have this, right? 1, 2, 3, 2, 3, 4. Give it a shot. Let's see what's come out of it. Expected is this, so can I say 3 to 4 dot add 1, 2, 3, yeah, dot add 2, 3, 4. Just trying to see what is the required. Okay, can I just add integer? None type has nothing. Oh, hold on. I have to do. Yeah, let's do this nested integer, right? And then I just say ni.add 3 to 4 ni.add. I think it's fine. 1, 2, 3 ni.add 2, 3, 4. And then when I return ni, right? Let's see. Add integer directly is not valid. Okay, so it's not valid. Maybe I need to wrap around. Okay, what if I wrap around? Let's see what's going to happen if we wrap around. This is just like figuring out the library, the APIs. Wrap around works. What if I start with 324 and then add more things, right? How's this going to work? Then we say this is an integer by itself. Ah. Okay. How about I add this and I change this into a single value, 324. How about this? What's going to happen? That is not correct. Okay, now I see. Now I see. So single value has to be a single value, and the list has to be a list. Okay, fair enough. Fair enough. But in this case, then I need to know how many are there, right? Because if there's only one, then I shall not create a new one. And and I need to pop out the total number, right? I need to pop out the number. I need to know how many there are in it in order to determine what I should push in. That is so annoying. That's very annoying. I mean, I can just run because I want to pop. I want everybody pop out, and I cannot. I have to. Get list and get integer. Okay. Let me think. How should we do this? What if we always add new things like this, right? We hold this, we hold this, we hold this, and then when I get a list, I get a list of nested integers, and I get integers, but I cannot get, like, say, the first one. Yeah, I cannot access the first one. I can only get if it's the single one. I think I'm gonna give up on this idea. I think I'm gonna just, regular. Alright, we'll just go regular by popping them into a list, and then we just run the list. The runtime will still be on. We just have an extra step. Yeah, screw this. Screw you. And then go left to right. Yeah, screw you. Alright, I like left to right, and this is the result. Oh, are you sure this is the result? We're just gonna put it into it, right? And then I'm gonna pop out. Let's not worry about this for now. Let's just put smaller than n, right? And then if it's a left bracket, I'll push it in. And then if it's a right bracket, then we're gonna do something. Otherwise, if it's a left bracket, if it's a value. Now it's gonna be a real value. If this is if this one is in, right? In 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and a minus sign. Let's go to the minus sign. If it's in this, then j equals I, n equals to 0. So while it's j is not equal to this or not equal to this, right? And then we don't have to do this. We can just say 10 times n plus int sj, and j plus equal 1. Then we don't need j. We can just use I. Here we can just use I, because we don't have to compute how many powers to do. So this will just be I, right? Blah 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 blah, and then this one gonna append just the value itself. We're not gonna do anything, right? And then after every time I gonna be plus equal 1, but then here I gonna be minus equal 1 because I already go to the next one to identify as not, so it's gonna be minus equal 1. So when I come out, I plus equal 1, going back up, right? If it's this, keep pushing in. If it's this, here is the thing, right? So what do we do? If it's a right bracket, so we're gonna pop, right? So we're gonna say values equals this, and we'll say while stack and stack. The last one is not equal to a left bracket, right? If it's not equal to a left bracket, then vals dot append stack dot pop, right? So we're gonna pop all the numbers, numbers pop, all pop, and then stack pop again. So this one is to pop the left bracket. Now we've done all that, then we need to see if, right, if len vals is equal to 1, if it's a single one, then stack dot append nested integer value equals vals 0, right? Else, then we're gonna say ni equals to nested integers, right? And then we're gonna say for val in vals reversed, right? In vals reversed. Then we're gonna do ni dot add nested integers val. And once we've done all that, stack dot append ni, which actually we can do. I think we can say set integer, set this to hold a single integer. So we can just do ni equals to nested integer, right? And if it's this, so we can just say ni dot set integer value, which is vals 0. Otherwise, ni doing blah blah blah, and then stack append ni, right? And okay, all right. So then what? Stack dot append this, and then we have another bracket, right? And then we're gonna pop these out. We have another bracket. What about I? I is equal to the right bracket, so I plus equal to 1, so I doesn't change. Right? So we keep going, maybe another right bracket, and then we're gonna pop things out. All right, when the vals this, we're gonna append this, append pop, pop, right? And then if it's hold on, it depends. it depends. If this is equal to 1, we need to see if it's equal to 1. Then, if, right, if val's 0, how do I know if it's an integer or not? It might be an integer, it might not be an integer. I do have is integer. So maybe we shall push in. Yeah, I think I shall push in nested integer. And then, if it's 1, then we can check, because everything is a nested integer, we can check if this, right, if val's value dot is integer, right, I think this one, what, is integer. If the nested holds a single is integer, right, if the single one is an integer, then ni will equal to val's 0. Alright? Else, that doesn't matter. If it's a single, if it's a single one, if it's a single one, then ni equal to val's 0, right? It could be a list already. It doesn't really matter. It doesn't really matter. We just want to know the new nested integer. So if it's 1, it doesn't matter. It's always going to be this, right? Else, if it's not 1, that means we have several, right? Or several, and then if it's several, then we just have to add it to it, which we can just do like this. And then we append this, all right? Depending on how many we have. And then we append this. Okay. And then the last one, we'll get it out, or pop, and then we'll pop it in. So the remaining in the stack, All right. So now we're going to say, the result is just whatever is remaining in the stack. So I'm going to return stack 0. If it's a value by just a value by itself, then we will hit here, which already give us this. So yeah, I think this one shall be right. Let's try it. String out of range. If this equals this, how do I out of range? The first one out of range. If this or this, and I is smaller than n. Yep, I forgot this. I need to be smaller than n. I'm still out of range because I smaller than n need to go first because it's a short circuit. So I smaller than n need to go first. Invalid base with 10. Huh? How? I say, it's not, it's and. My God. Then all 3 is and. Right? If it's this, and it's not equal to this, and it's not equal to this, then we do all this. Wait. Wait, what? Wait, 389? wait, hold on. Hold on. It doesn't make any sense. Come on, man, this doesn't make any sense. How is it 389? Wait. 10 times n, y parentheses, right? Parentheses. No, not parentheses. No. This doesn't make any sense. Huh? Why is 324 turn into 389? Where does 8 and 9 come from? Alright. Alright, let's print n and si, right? So let's see if anything's wrong here. We have 3 n and I, si, and we have out of range. Yeah, of course, out of range. Let's do it here. So 324. I have start with n is 0, and then this is 3. So next one comes is 3. That's 2. And next time comes up, it becomes 35 and 4. It should be 32 and 4. What the hell? 10 times n, right, is 3, and plus int si plus 2 should be 32. What is happening here? I don't understand. 3, 2, n plus, n plus equal to, n equal to. That shall resolve the issue. Yeah, let's run a few more. Let's add some negative value, how shall we? Alright, and then we add more here. Yeah, we can add this. Right? We can add whatever we want. And we can even do more evil things like this. Alright, let's see. This is very evil. S must contain value. What did I do? What did I do? Oh. I don't think this one is allowed. Empty space is probably not allowed. Invalid with base 10. Yes. Yes, invalid. Come on, man. Come on. Ooh. So if Si is equal to, then is that -1? -1 will be -10. Oh. It'll be this. It'll be like this. The sign, right? The sign equal to 1 equal to -1 if Si is equal to this sign, else it'll be 1. And Do it again. Sign is equal 1. And if si is equal to -1, right? Minus sign. Then, then sign equals -1 and I plus equal 1. And then we do this, right? Blah, 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 blah. At the end, n times sign. How about now? Still not correct. Because the last one. Tricky. So the last one. I say, because it's left bracket, left bracket, left bracket, and a value. I turn the value into nested integer, a right bracket. All right. Once I have a right bracket, if I have a right bracket, then I need to append. So, yeah, I think my initial one analysis is right. So we always need to add. We always need to add. Oh, in this case, isn't this the same? We just add every single one. All right. We add. Yeah. That shall do. This shall do. Let's see if we can make it even easier. I don't think we make it. We do have to pop everything, and we're gonna pop this, and do this, and reverse it, and do this and add it. And this is to handle to parse the number. Yeah, I think this one shall be right. There we go. So I have a couple of changes. Yeah, these I don't think white people don't like it. I think it's pretty cool. It's a question with a lot of, what should I say, pitfalls, right? A lot of pitfalls. It took a while. It took a few tries to fully comprehend the API of nested integers. The result is that each time when we push an integer into the stack, we must push a nested integer. Another tricky part is parsing of. Why do you do it that way? I just realized. I could have, if this is this, I can just keep going and using, I can parse it myself. I can parse it using Python to parse. Yeah, I can use Python to parse. Well, another tricky part is parsing the negative value, right? Negative values. But I just realized that we can actually ask Python to parse it for us. So yeah, I'm going to ask Python to parse it for us. So all I need to do is do this. Actually, j equals I, right? And then we say while j is smaller and sj is not equal to, and then this one not equal to, then j plus equal 1, right? And then we don't need any of this. Just start append int s I to j. Yeah, I to j. And then I equals j minus 1. I'm going to use Python to parse it for us. We don't have to figure it out ourselves. Yep, might be even faster. Yeah, slightly faster. A couple milliseconds. So runtime is ON, although we have to do this, but everything is O2N to be specific. And this one is 72 and a 66% ranking. Okay, let's just take a look. Go to discussion. I am going to thumb up. I don't think it's anything wrong with it, right? Oh, it's fine. I don't want to see it. The golf eval. Oh, ah. Okay, you do that? Oh yeah, I guess you can. Char by char. Nah, I'm not gonna read it. I think the basic. Oh, that's not the same question. The basic idea is the same. The basic idea is the same. But maybe they have. Hold on, let me see. Do they have to reverse it? S.pop. Oh, they are reversing it. Nested integer. S equals to this plus. Oh, they reverse the entire thing. Up into a list. And then num plus S.pop. If num, return nested integer. Okay, this is to get a value. If num will do this, return nested integer. If not, then S.pop. Okay, and then we do this. List is this. While it's not a right parentheses, we're going to add. If S is this, we're going to pop. Yo, honestly, I don't understand. I don't understand what he's doing. Honestly, I try to understand. So he reversed it first, right? So it's reversed, and I put this at the front. Okay, so I pass it in. Well, this is not. Well, it's not going to be initially. And then, where do you handle the other? Because you only call it once. Oh, add. I see. I see what you're doing here. So while this is not a right bracket, because I reversed it, right? Reversed it, so what if it is a right bracket? Well, it's not a right bracket. Then I'm going to add. What if it is a right bracket? S.pop. And then return list. Hold on. I reversed the entire thing. So the right bracket goes first. It would be right bracket, right bracket, right bracket, right? And of course, the first one is this. Oh, and then I'll go from the end. Okay, so I go from the end. Oh, just because if we do that, we can naturally pop. Okay, I see. So left bracket first. So left bracket pop, right? And then, okay. So if this is not, then always pop it. And then list equals this. And then while it's not a right bracket, then we're gonna compute the next integer. So we'll do this again, right? Recursion. So what we're saying is, under the recursion, after the recursion is done, it will return, right? Will return on the number, right? Return on the number. So a number is coming out. I will add it to it. Okay. That makes sense. So we'll add it to it. And nesting it. So it does one number at a time. One number at a time. Alright, we add to it. If this will pop, go back up. If it's not a right bracket, we'll keep add another one, blah blah blah. Once we're all done, pop, gonna pop to the right bracket, and then return this list. I see. Anyway, why do people don't like it? I don't have any I don't know. Clarification, that's probably the reason. Clarification. They're asking for clarification. Yeah, that's true. I won't go so far to call this problem dumb. It's just it does require more. I mean, this is like more real life situation, right? You get a something called a nested integer. They have tons of APIs, and then you need to decide which one to use. And just like real life, the documentation might not be the best, so you have to try and error just to see which one, to see how the behavior, whether the behavior satisfies your understanding, meets your understanding. Yeah. Overall, it's good. I think it's good. All right, that'll be it. I'll see you guys tomorrow. Adios.